Good day, everybody. I'm very lucky to be here and very lucky to make for me the very first online session in such a audience. So before it was always like personal with EWM members or clients or sales partners, and now we have the possibility because of the shutdowns and because of all the things what happen. We have the chance to talk to each other and to make the presentation. And today I brought you a presentation about welding 4.0 in Industry 4.0, and we want to use the time just to talk a little bit about some examples from customers. So I have brought you a lot of things from customers, a lot of examples and things where I have been the last years, and the benefits what the digitalization is bringing for the welding industry. And as we start with the presentation, our challenge or our mission is of course welding, or it still is welding, even if we talk about digitalization. And let's just compare the welding technology or the welding itself from today with welding, for example, 5 or 6 years ago. And I have talked to a lot of welding engineers in bigger fabrications here in all over in Germany, and for example, customers in Singapore and customers in Poland, in the Czech Republic, in Belgium, in the Netherlands, and all of them answered me the question in the exact same way. And they said, you know, the biggest difference is that 5 years ago, for example, we weld a bridge. So here in Germany, we have a lot of bridge construction sites. We are doing a lot of bridges. And they said, you know, if we weld a bridge or part of a bridge 5 years ago, we have done approximately 100 pages of documentation. So, for example, the certificates of the welders, the welding procedure specifications. So all the documents what are needed to make a documentation for the end client. And he said, and comparing to today, the product is still the same. So we have the same bridge, we have the same materials, we have the same welding wires, we even use the same machines. We have the same people that are working for us. And the big difference is that the documentation, what we are doing today, is 8 times bigger than 5 years ago. So 5 years ago, we needed 100 pages of documentation. Today, we are doing 800 pages of documentation. So most of the time, we need to order some trucks to bring the documentation to the client together with the bridge parts. And so the difference, or what we see today, is that we are using a lot of different things, or a lot of different items are coming to us. So for example, repairs. Who's responsible for repairs? Who is repairing the welding machines? Or what is with predictive maintenance? Who's responsible for that? Do we have any scales? Do we have any time frames to do repairing on welding machines or on torches or whatever? What's about the welding time? Do we know how many time we need for a total project? What is about the calculation if we do such a product, or if we do such welding? What about the quality? Can we assure that the quality is always on the high end or on the high level? How can we assure that? How can we prove that our quality is the best in welding if we go with our product to our clients? What about with rules and standards? So a lot of auditors are coming to the production side and saying, hey, okay, what's about the rules and standards? Can you show me some documentations about that? What is with the non-destructive testing? So if we do the non-destructive testing and we see that there is something and we need to maybe weld something again, or we need to repair something, how many time does this take? And if we look on welding 4.0, then we have a kind of, it's a kind of quality circle of welding. So the biggest thing what we need to know is, of course, the component information. So we have a lot of component informations from our construction department. So we have drawings, we have measurements, and all that kind of stuff. Then we have the welding equipment. So what kind of welding equipment do we require to make this bridge or to make this product ready? And then we are thinking about predictive maintenance. So how does this work in all the production sites? So how can we assure that our torches are always cleaned? How we can assure that the contact tip of the torch is good and that the welding quality is the same like from day one? Then we need to know what kind of process do we use, or what kind of process have we used in that project? What's about the employee? Is he certified, he or she? Are they certified? Do they have the needed certificates to make this happen, to weld in that project? And what about the documentation? So how can we do it? Is it pen and paper? So is somebody around that is running in the production and looking on parameters from the welding machine? Is somebody that is running around and making notice about the welders? Okay, who's welding where? What is the component info? What is the seam number? What is the non-destructive testing on that seam number? So how are you doing this? I think you can also answer these questions in the chat function below. So I would like to know, how are you doing the documentation of your products in your production? And then we can talk about that later on. And what about monitoring in real time? How can this work? How can this look like? So are you recording something? Are you recording some parameters? And are you recording some parameters that are inside the WPS? Or how can you be sure that the current and the voltage and the wire feed speed is used, that you have certified in your welding specification? And then we have the result, and this ends then again in the component information. So you have a circle that you always have to overwatch, or this kind of informations you are searching for the final documentation for the end client. And the requirements are very simple. So you need the network that the equipment can work in it. You have to have digital welding documentations, digital qualification of welders. So most of the time it's on paper still, and we need digital information about the component. And if we look on this drawing, then I have a comparison between the conventional process in the documentation. I have a comparison to welding 4.0. So in conventional, of course, you have your preparation. You prepare everything before welding, then somewhere you start welding. So this is a very easy drawing, of course. Then you have the welding itself, and after that you have the non-destructive testing. And if you then see that, okay, this or that is not good enough, so we have to re-weld something, or we have to repair anything, then you go back and repair. After the repairment, you have again to wait a little bit till it's cooled down, because of course you need time for the cooling. You need to look on the heat in the seams, and then you have to weld again. And after welding, the test comes again. So what about real monitoring of the welding process? Why do we need, or why should we record welding parameters? If you look here, it's the preparation, then you have welding and the monitoring in real time. And during the welding, you have informations about how the potential of a mistake can arise in that specific weld. So you have the possibility to react even before you have the non-destructive testing. So that means if you see already in the recorded data that here's something wrong, that this cannot be, the welding parameters are absolutely not correct, or we have done some mistakes there, then you will be informed by the digital system, and you can decide even to repair or go for testing. So that means in this period you can save a lot of time, because you have the possibility to react even before you test the work when it's done. Another big thing is the predictive maintenance. So if you go on the conventional way, then a lot of times if I enter a production in welding, then the welders, they are using the welding machines and the torches for work. And of course, a welding torch is, you weld with a lot of heat, and that's the reason why the welding torch is getting broken sometimes. So you have, if we look on the contact tip, for example, the contact tip needs to be changed, and the most of the time it will be changed just then if you cannot weld anymore. So your indicator is, okay, the welding machine is not working anymore, and then we are going to change something. But the problem of it is that you are welding in a good quality because your torch and your wire feeder and your welding machine are in a good condition. But as soon as your quality or the quality of the contact tip is going down, the quality of your welding is going down. And then the big bang is coming. So you have the lower quality range up here if the material is just, you know, getting broken, and then you have to do maintenance. So you maintain the torch, you maintain the welding machine. Even sometimes you need then to maintain the product itself, and then you start again. And this is always the running circle. With predictive maintenance, if you have a system that gives you a feedback about when to change something in your system, you will get a maintenance message in XNet. XNet will show you, hey, look, you have welded now for example, 20 hours in welding time. So look on the contact tip, change it before the welding stops. So you have prepared maintenance times, and the quality is not going down because you have constantly the same quality, because you're constantly maintain your equipment. For welding procedures, to digitalize them and to have them in the same kind of system, we have improved, or we have done a lot of work on the WPS templates. So with XNet, you can have your own WPSs, or you can make them in XNet and to have them digital. What we have done here is a drawing tool that is reacting on your typings. So if you type in, for example, 15 degrees, then the drawing even will change, so that you can see, oh, all right, if I do some preparation here, if I do some preparation there, then the drawing is reacting on that what you are typing inside the system. You can print it, of course, and even the barcode will be there, so that you can afterwards scan the WPS to have it in the final documentation, so that you know the connection between the part and the seam number with which WPS was it weld. The same we have done with the welder management. So you can have the certificates of the welder inside the system, and you will be informed about the prolongation. So a lot of times, if I am in the welding production, then the prolongation is done by Outlook. So the welding engineer, he gets a message from Outlook, and Outlook is saying, hey, you need to do some signatures for the welders. In XNet, you can do them in a digital way, so you can approve, or you can prolongate the welder certificates in a digital way, and you have them all up to date. And the system will inform you if somebody is running out of certificate, and you have enough time to react on that. What's about the component? So if you have a component like in here, for example, we are welding here some seams, and I have created in XNet a technical fact sheet, or call it I don't know, work order, for example. Then this work order will give you a kind of barcode and an idea how to start with the welding, or where to go, where to start with number 1, number 2, number 3, number 4. Everything is connected then to each other. You have the WPS for every single weld. You have the welder who can qualify himself on the welding machine with a kind of key, and all these information will be connected to the higher barcode here. So that means the component number, you can search in XNet and get all the informations about the component. This is the dashboard, and one of our clients, it's the client GEA in Holland. They are using XNet for their welding production, and you will get some information about the welding machine. So what are the welding machines doing? For example, you can see here on the symbol that the welder is signed in, or he's logged in, but both machines, they are now in standby, so they are more than 50 minutes, there's no arc. You have some kind of consumption display, so that you can see the comparison between today and yesterday. So in fact of energy consumption, or wire volume, shielding gas, plasma gas, and so on. The welding data, and of course the welder qualification. So if you have more welders than I have here just one guest, then you will have the information about all your welders. If you weld and you have a monitoring on this product, then the system will give you information about some possible errors. Okay, so it doesn't need to be an error. It is just a potential of an error area. So if you have it after the welding in red color, then you know, okay, here I need to look on it. I need to supervise this welding. So what is here happening that I have it in red color? And you see here in start, you see here the how long does it take? So it was a weld of 22 seconds. You have the seam number, the job number of the machine, program number, then the current, the voltage, and the wire feed speed. What we have done here is to make kind of component management. So if you say I have a component with a certain barcode and we want to weld it, so let's search. Sorry, let's search for this barcode, or let's search for this specific component and get the information out of it. So if you jump into the recorded data, then you can see that these are my values, my minimum and my maximum value, and this is the actual weld. So I think it's pretty okay, but I would look on the end of it. So what happened here? What is this? Why we're going so down here and then again up? So is it something because of the torch, or is it some dirty stuff on the plates or whatever? So you have the possibility to overwatch it, and the info is here about. So you can see the component information. You see this is the seam number 8 on this specific component. Of course, you can do a calculation out of it. So, oh, excuse me for the screenshots. They are unfortunately in German language because they are made from another colleague of mine, but I will translate if needed to. So this is a kind of calculation sheet. If you do the calculations out of XNet, so for example, if you say I have a component number over here and all the component welds, what I have done, I want to have in a calculation. So I want to have calculated everything together, so I have a rough idea what this costs me. And you have some energy consumption, you have the wire volume, you have the shielding gas, and you have, of course, the duration. And we see that, for example, here of 2 minutes and 25 seconds of welding, it's about, in this case, roughly €3 what we spent on that, some kind of short welds. The welding machine is a big indicator because you will get an information with the LED light on the welding machine. So even the welder is then informed if everything is okay. So blue is like ready to weld, everything is fine. So everything is signed in, everything is scanned. Green is if the welding is okay. Yellow is when the machine tells you, hey, here's a warning. So maybe you are very close to the areas that we need to look on it. And error is then the potential error. So you know that you overrun the minimum or maximum value what you could. So have a look on this, and the welder is informed by the light of the machine. The maintenance is done with some timers that you can set. So for example, like I said, the contact tip, so remaining 8 hours and 43 minutes, and then you will get a message about to change the contact tip. You have the shielding gas system, wire guide, or wire feeder 1 and 2. So you can set different timers, and the timer will give you an information about when to change something, or when to do a cleaning, for example, on the welding machine. So you can have some text fields here. So replace contact tip, for example, or blast the liner, or check the gas hoses, whatever. And this is just kind of to give you an idea about the monitoring, or the summary and evaluation. So if you look on it, then you can see what kind of values we are recording. So it's the welding current, the welding voltage, the wire feed speed, the shielding gas, and even the motor current. So the current of the wire feeder unit, because we as as a welding machine manufacturer, I have noticed that a lot of mistakes, I would say more than 70% of the errors when a customer is calling us and saying, hey, the welding machine is not working properly, the more than 70%, you can be sure that is a problem of the wire feeder, or it's a problem of the torch. So maybe the wrong rollers, the rollers are closed too tighten. The welding torch is broken, the welding torch is damaged, it's the wrong gas, whatever. And with the motor current, you can be sure that the hose package and the hose package of the welding torch, that this is not damaged or it's not dirty. So if you have a current and you can overwatch it and it's going, for example, more than 3 amps, then you can be sure, okay, I need to look on it. Maybe the torch is broken. Maybe the contact tip is the wrong one in front. So this gives you an idea about your welding process in the production. You can have a screen about your efficiency. So if you say, okay, we have 3 shifts, shift number 1, shift number 2, shift number 3. So we have kind of, yeah, it's just a picture, good to know. So how efficient are we in our shifts? And last but not least, you can export the data. So we have a very open database. It's an SQL database. So that means that you can, for example, download some BI tools from the internet and then make your own graphics, make your own graphs. So this one is created by a colleague of mine. So you can use BI tools to make some stats or some graphics for your self-use. And the biggest benefit is that if something happened, then you have recorded data. The best example was, I think it was 1 year ago in Alkmaar, it's in Holland, from a soccer or from a football stadium, the roof came down because of wind. It was too windy on that day, and the soccer players, normally they would play on that day, but they said, no, we cannot play, it's too windy. And they canceled the day, or they canceled the play game, and that was good because the roof came down and damaged more than 200 seats. And luckily nobody get hurt, so nobody was in that stadium at that time. But of course a lot of questions rained down on that welding specialist, because everybody was asking why the roof came down. Show me the parameters of all the welds, show me the people or the certificates of the people, where they're certified, what's about your WPSs, was everything done by the rules? And if you use a kind of digital system, then the documentation is done kind of automatic. So you have much more time to do important things and not to use a lot of time for paper documentation. So I hope I gave you a short introduction. I mean, it's a really big thing to make digitalization and welding production. So I tried to shorten up the presentation. Normally I do some kind of presentations in 2 hours. Today it was 20 minutes, so I hope you have a lot of info yet. And I'm very looking forward to have a discussions with you guys, and you have the contact details. So if you need some informations, if you want to just talk or want to have a chat with me and have some questions about it, then just don't hesitate to contact me and we can get in touch together and just talk about digitalization. Thank you.
Yes, thank you very much, Stanislav. That was an interesting and very well understandable presentation for me. I'm also amazed. Everything seems to be, to me, very neatly arranged in your presentation and assumable also in your software, what I have seen.
Thank you.
I think
good feedback.
Your customers must be very thankful for that you are addressing this topic. The need for documentation has gone up by factor 8 since about 5 years in the past, you said. That leads me to the critical question where this might lead us in the future. But the question is, of course, not addressing you, more the more our legislative side there. So it's going up all the way.
Yeah, that's true.
Let's look up for the questions. I don't think we have many questions here. Wow, we have just one question here. If your fine presentation will be available for download. I think we can arrange that anyway.
Yes, we can arrange that. So I think I can. Should I send it to you, Torsten, and then you can upload it, or what can we do?
I will talk to Miss Simon about that, and we
Yeah.
will
Okay.
arrange that after
All
this.
right.
Okay.
All right. But we have.
And
Sorry, we have all these informations from the software we have on our homepage. So if you go to EWM group.com, then you will find the EWM software, and there we have. I think it's on my first slide. There you can find all the informations about Ixnet and Welding 4.0. So it's here EWM-group.com, and then it's product and software, and there you will find all the infos you need.
okay, thank you very much. I think it will also be uploaded to YouTube afterwards. So no more questions from the audience. Then let me finish it with a few final words. As you might know, the web sessions here are originating from the situation that METAV Fair had to be postponed due to the worldwide COVID-19 disease, and it will now be taking place at the end of March 2021 in Düsseldorf. Maybe we have the chance to see us there or at any future venue, such as the next METAV Web Sessions. I wish you all a pleasant stay, and thanks again to EWM and Stanislav Wiens. You can find the agenda of the upcoming web sessions on the website IndustryArena.com, and all the participants can also find a participation certificate in the webinar planning tool for download. Thank you again, Stanislav, and goodbye.
Thank you. Goodbye.